Alright, so in the previous video, we discussed navigating Elevate. So what I did was I went to the eText, which was right up here, and I just launched the teacher eText. So here I am. I went over to the table of contents and selected Unit 1. So this is where I currently am. At the beginning of every unit, you're going to have some pieces to engage students in the topic. On the sides, it'll give some why behind the what, a storyline. I would recommend reading that so you can reiterate that in student language. Also, whenever you're going throughout the unit, you're going to need these things. Please let us know if you need help getting anything, but this is at least an idea of all the things you're going to need to gather for the unit. You've got an overview of up here of the lessons that you're going to go through and the topics associated with each one, your standards, your essential questions. This is your topic page. On the side, it also tells you resources that you can use to engage students. I would use these in my centers, or when we get into planning lessons, if you have extra time, these would be great to add at the end. Just like MyView, it's got a big idea, and then we're going to slowly work our way through that big idea until we get to the end and we do some kind of project or capstone to synthesize our learning. With every single Elevate through all the grades, it's going to connect the topic to a career, and you're going to get a letter or something from someone in a specific career, and then we're going to work through that to make sense of it. So each lesson takes us on a quest. On the side, you'll see more resources to use to engage students, and they explain what it is, what it does, and these are for you to utilize. Moving further, they usually start with a UConnect lab. This is, again, to get students thinking about why did that happen, and then we're going to find out later. And then we want to bring it back to literacy and read something and then make connections to it. This is going to be your best guide when you're going to plan for Elevate. The interesting thing about Elevate is the authors of Elevate did write this program, realizing that many grade levels just squeeze science in where they have extra time or they overlap it with things. Sometimes it's not done every day. So they wrote the curriculum to keep that in mind. Right up here, it says if you're short on time, you can focus on just the yellow resources. So if towards the end of the year or you realize you're just not having as much time for science as planned, as long as you do the yellow resources, the students should grasp the topic. Now, if you have plenty of time for science, you can always throw in the ones that are not yellow to increase their knowledge. If I were planning my lessons, I would map out the activities in order based on my time limit. So, for example, if I am a second grade teacher and I realize I have about 30 minutes a day for science, I would definitely be able to do the Jumpstart activity in the vocabulary app, but I might want to use some of those supplemental activities on that first page I showed you to fill some of this time and let students explore the topic. The interesting thing about these lessons is, unlike Envisions and unlike MyView, these lessons are not meant to be one lesson per day. Your lesson could take you 4 or 5 days even to get through. So it is not supposed to be paced where you do all of this in one day. It's not even meant to be paced where you do this category one day, this category another. It's just meant to go in order and to make time for it as you best see fit. And I have a really hard time wrapping my head around that as just like a very type A personality that I am. So it being a little more organic and flexible honestly makes it almost harder for me to think about, but it's meant to be at a benefit to you, so there's not as much pressure and time crunch and feeling like you can't make the resource work for you. All right, so as you work your way through the lessons, you'll see they have some pretty long components. Like this page, for example, is the one where they suggested should take 10 minutes. There's a vocabulary app associated where the kids get to practice with these words. Also on those previous pages, there are some games. So on a day like this intro day, I would do the lesson, do the vocabulary app, maybe supplement with something that my team used last year, and then let the students play one of the science games. However, on the next day, this activity is estimated to take about 30 minutes, so this would take the majority of my science time. So you're really just, like I said, going to have to make it fit for you. Continuing to go through, I don't recall the exact times that they suggested for these, but I would go back to that first page that we looked at and just kind of map it out. There's also a pacing guide somewhere near the front of the book. I am going to pause the recording and go back to the pacing guide. Okay, so I had to go to the front of the book, and it's called the pacing guide. It's not in a unit because they pace out every topic, but right here they give a suggested approximate number of days that it should take you. So right here you could see that the lesson content should take 24 days. So if you, when I think about it, there's 6 lessons. So like I said, you don't do a lesson a day, and this is where I really was struggling to grasp my mind around it. Your labs, you should get plenty of time for. The quest, which is the synthesis at the end of bringing all the pieces together, and the kids do a project. You engineer it is where, again, you promote that independent thinking, and there should be 1 day for assessment. The assessments are really interesting because there is a performance task, and we'll get into that in a minute, but the kids design experiments. So it really promotes that student-led thinking, student ownership. And when I was speaking to the curriculum expert with Elevate, he said he tested it on his kids, and he had a preschooler at the time, and the kid's now going into 2nd grade, and he still remembers designing his own experiment. So it is really impactful if we can get our kids to think for themselves. So just so you know, it is paced out up here. It's approximate, and in fact, if you count all the days, it's more than 180 days when you put all the units together. So just know that it is meant to go at a slower pace and not to cram everything into 1 or 2 days. All right, back to where we left off. I'm going to take you to the assessments just so you can get a quick overview of these. I personally feel like 1 day for the assessments felt too short, and some of the other stuff felt too long. But again, just see how it all fits in your schedule. They have different kinds of assessment. They have some more formal assessments, and then they have the performance-based assessment. So here they have those very state-written style questions, and I do think these are great, especially since we're leading up to that science test in 5th grade. So it's getting them used to that type of language. And then we just keep going. It's got a full assessment in the book, so no need to create it. Then it's got science assessment practice, and again, back to that state-centered, I guess you could say, way of thinking. This is great. Here's your answer key. You've got the graphs in there. Okay, so here's that performance-based assessment I had mentioned earlier. And really, you want to get your kids to a point where you provide them the materials. You have them do this completely on their own independently. Now, since this is a new idea, it's probably going to need to model. You're going to need to model some pieces of it as well as give guiding questions. So the procedure is here, and then you want to allow about 45 minutes for this part, which is why I said I don't see assessment happening in 1 day. And if they need more direction, they tell you how to provide that direction without giving answers down here. Then they continue, and they're supposed to, at the end, analyze what they did. I truly think this is such a cool way of thinking, and it's going to take time since we're switching from science being very procedure-driven and instructor-driven to now having students take everything that they learned and be able to conduct their own experiment with just a little bit of instruction and materials. So we're creating those problem solvers and those active thinkers. And down here, you've got a rubric on how to grade them. So by this point, they really should be able to demonstrate mastery in a fun, applicable way.